Ever took a wrong turning and got lost? The further you go, the more trouble you're in, but you still keep going? Well, this video is a coding equivalent. So we're going to look at how to solve a problem in Python. So the background is the Fun and Games series. We wanted to create a card game that's like Rummy, but with 7 cards. That seems quite straightforward. So we had a look on the internet to do some research, and there didn't seem to be any videos on YouTube and nothing on the internet. No bells there then. So we started coding the program and we pretty much finished, and we just needed to check to see if the game was finished with the correct hands at the end, which seems quite simple. It shouldn't take that long, should it? Oh, it did. Well, would you like to see what happens? If you're a coder, you might try this problem yourself. And if you're not a coder, you might want to just follow along with the logic. So the task is to check to make sure a hand is complete at the finish of 7 card Rummy. Let's code. We're going to start off with what happened. We started off with a hand and a function called check end. And in that function we check to see the cards like 3 and 4 of a kind and the cards that are called runs, so 3, 4, 5, 6 for example. So it seems quite straightforward. So that's like the beginning of how we just started to code, just to see if it was relatively straightforward. So we can run that for example, and you can see there we haven't inserted the code. So not too bad to start off with. So check the same, pretty straightforward. We just need to check if the card is in the hand 3 times or 4 times to see if it's a 3 of a kind or a 4 of a kind. So that's quite straightforward. So not too much of a problem there. So you can see there we've got 3 of a kind with the 3 4s. Now, okay. So what about for a run? So we just need to check if a card is followed by a card which is 1 more number higher, and then 2 more higher, and 3 more higher. So we can look at the code. It's quite long. And also if we've got something like 4, 5, 6, we don't want the 4 or the 5 or the 6 to be part of the 3 of a kind or 4 of a kind. So now it's starting to get a bit more confusing. But that's the code we wrote, and we can pass that back into our function of checking to see if it's the end. So now we can run that and we can see problem, it's got 11, because once you've got for example a run 5, 6, 7, 8, then all of a sudden 5, 6, 7 and 7, 8 are runs as well, so not great. Okay, so what we can do is if we found the run already, then we can kind of remove some of that, and then that won't be a run anymore. So again, it's starting to get a bit more confusing, so let's just remove something if it's been found already. So we can change that code, and then hopefully then when we run that we've got 3 and 4, so we've got 3 4s and we've got 4 cards, 5, 6, 7, 8. That's a run. Well, let's try testing it to see if it works on all hands, and this is the problem. It seems to find hands that it says it's the end when it's not. Oh dear. So what we're going to do, so let's take a break and let's play the game and see how it works when we play a game. So here's a game of Rummy 7 card. We've got a hand, and then we get a card that's on the stack. We either play that card or we get a new card. So as you see, we get offered the card on the stack. If we don't want it, we get a new card. So we can either take that new card or we can say no, and then we get another card from the stack. So we keep doing this, and we can improve our hand. Here for example we've got 2, 3, 4, and now we've got 6, 7, 8, 9. So we get rid of the ace, which we put in A, and then you can see we should have finished. So that's a bit strange. So now we don't want the king. It says end of game. So the game seems okay. But what happens? How do you check the cards? Well, we keep coming against problems. We keep coding to try to find a solution, but it's not working. So what would you have done? Would you have just kept on going? Would you have redesigned and started again? Would you have given up? Maybe look on the internet, see if someone else has got the answer, or perhaps even ask for help. Tell us in a comment, what would you have done, A, B, C or D? Well, we decided to kind of start again, but reuse some of the code. So we had like check same and check row, and just trying to change these slightly to look at each scenario to start off with. So for example, if you've got 4 of a kind and 3 of a kind, then that would be the end of the game. And if we've got 2 3 of a kinds, then that would not be the end of the game. For runs, we want to check to see, first of all, if we've got 2 runs, 1 of a 3 of a kind, 1 of a 4 of a kind. So you can check each scenario and just take it one step at a time. So check same and then check run, and then we're going to look to say, well, if we've only got 1 3 of a kind or 4 of a kind, then that's not the end, or if we've got 2 3 of a kinds, it's not the end. And we can just look at each scenario. So we add just pieces of code for each type: 3 of a kind, 4 of a kind, and the possibilities of 3 and 4 of a kind merged together. So we're just showing you how we added the code, and once we did the easiest part, then we start thinking, okay, how can we deal with the more stranger the parts, the anomalies? So for 3 of a kind and 4 of a row, or 4 of a kind and 3 in a row. So we wrote the code called check anomaly 1 and check anomaly 2. And in this code, basically we do the same thing, except when we find the 3 of a kind or 4 of a kind, then we actually just remove those cards. So if you like, we're breaking the problem down. So we do that with the 3 of a kind first of all in the first anomaly, and then in the second anomaly we do the same thing, except for we remove 4 of a kind. And at the end of those functions, if we find the 3 cards remaining or the 4 cards remaining, if they are correct with our previous code, then that's the end. That's a hand that will be the end of the game. Now, once we go for the obvious scenarios, we were remaining with these 2 runs that caused us the problem. So in our example here with the 3 4 4 5 5 6 7, that is a good hand to finish the game. But with the 4 of a kind and 3 of a kind, it works. But when we got 3 of a kind and 4 of a kind, but in runs, not so good. So we have to add code to check 2 runs. So we add check to run function, and this is going to check when we've got 3 in a row, then 4 in a row, and check 4 in a row and 3 in a row. So those 2 scenarios we're going to check separately. So here's the code. We're basically looking at the set of cards, and then we'd see if we've got consecutive cards, and if we've got 4 in a row, we remove those 4 and then see if the 3 remaining are indeed 3 in a row. Now, for checking for 3 and 4 in a row, we do almost the same. We check for see if we've got 3 in a row, and if we have, we remove those cards and check we've got 4 in a row. So that's the long, very long way of achieving to see if we've got 3 in a row and 4 in a row together. So then when we check our code with this quite difficult example with the 3 4 5 4 5 6 7 2 runs, we've left some test print statements in there. We've got our list, the 4 and 3 doesn't work, but the 3 and 4 does work. So it does tell us that hand is suitable to finish the end of the game. So we can finish just looking at our code, check end, we check the same and the runs. We're looking at the code at the top, we check the same cards, we check for cards that are consecutive, we look for the anomaly of 3 of a kind, 4 in a row, 4 of a kind, 3 in a row. So those are 2 functions to check 2 different anomalies, and we also wrote a huge amount of code to check for 2 runs by deleting the 3 of a kind or 4 of a kind and looking at what's remaining. So that was the finishing code. Subscribe to receive new videos designed to improve your programming skills, and if you would like to support the channel, please click on the bell and share using Facebook and Twitter. Okay, thank you for watching.